Let's take a look at reviewing for our final exam, and we're going to do a little review of chapters 1 and 2 today. Looking at chapter 1, section 1, here we want to review our points, lines, planes, rays, and segments. In part A, it says give two other names for line PQ. So if we take a look at PQ here, I can switch the letters and call it line QP. Or we can use the little letter up at the top, and we can also call him line N. For plane R, we can use any 3 points that don't line up in a line. So VSP or VST would be two names for plane R. Part B says let's give another name for ray, ST. That means I'm going to start here at S and go through T and keep going. Well, if I start at S and go through T, I'm also going to pass point P. So I can also call this ray SP. Now let's take a little side note here, and if I wanted to look at two opposite rays, those are rays that start at the same position, like point P, and shoot off in opposite directions. So the two opposite rays here would be ray PT and ray PS, both starting at P and going in opposite directions. Part C says name 3 points that are collinear. Collinear means that they're on the same line. So that would go to our points S, P, and T, which we can use on the same line, but we can't use those in part A to name our plane because it's only 1-dimensional versus 3-dimensional to get that plane figure. So again, our collinear points would be S, P, and T. Our 4 coplanar points would be V, S, P, and T. Remember the R down here doesn't have a point. That's naming the plane. So our coplanar points would be S, P, T, and V. D says name a point that is not coplanar with those 3 points, and that's going to be this top point Q, who's not sitting on that plane R. In section 1-2, the biggest thing that we went over was the segment addition postulate, which says that the 2 parts of the segment add up to the whole thing. And we use this quite often when we're dealing with our proofs. If we look at our example, we're given that our point S is in between R and T, and we're given some lengths. We're given that RS is 2x plus 10, ST is x minus 4, and RT has a length of 21. So our segment addition postulate says that the 2 parts on the inside have to add up to the whole segment. Writing our equation, 2x plus 10 plus x minus 4 is equal to 21. Now we can solve our equation for x, combining like terms. 2x and x will give me 3x. 10 minus 4 is a positive 6 is equal to 21. I can subtract 6 from both sides and get that 3x is equal to 15. Divide by 3 and we get that our x is 5. Now that we know that x is 5, we can plug back in to find the length of RS. 2 times 5 plus 10 is going to make RS 20. And if the whole thing is 21, that means that ST, which is x minus 4, 5 minus 4 is going to give me a length of 1. In section 1-3, we looked at the midpoint formula and the distance formula. Our midpoint formula gives us the point in the middle, in between our 2 endpoints. The distance gives us our length. So let's go ahead and look at part A. We're given that, let's go ahead and draw a little picture of this. R is at 1, -3. S is at 4, 2. And so if we want to figure out where this midpoint is, it looks like it's going to be right about there. So to find my midpoint, I'm going to add my x coordinates together, 1 plus 4, and divide by 2. And I'm going to add my y coordinates together, -3 plus 2, and divide by 2. So this gives me a midpoint of 5/2 and -1/2. 5/2 is the same thing as 2.5, and so I can see that my midpoint is forward 2.5, down 1/2. Now if I want to find the distance between an R and S, or its length, we're going to use the distance formula. And so we take the square root of the difference of the x's, 4 minus 1 quantity squared, plus the difference of the y's, 2 minus a -3 quantity squared. Four minus 1 is going to give me a 3 squared, plus minus minus becomes plus plus. 2 plus 3 is 5 squared. And so I've got the square root of 9 plus 25. And so if it's given as an exact answer, that would be the square root of 34. As a decimal approximation, let's see. Let's take the square root of 34, and that's about 5.8. In our next picture, we want to find the area of triangle AFE and its perimeter. Well, looking at triangle AFE, we can see that it's a right triangle. And so I can have my height, which I can count, and my base, which I can count, and I can easily find the area. We know that the area of a triangle is 1/2 base times height. And so if I count the number of spaces from A to F, we've got 1, 2, 3, 4, 5, 6. So he has a length of 6. And from F to E, 1, 2. So now I can find my area is equal to 1/2 my base of 2 times my height of 6. And 1/2 times 2 times 6 is 6. For the perimeter, we need this third side, the hypotenuse of this right triangle. And since it's on a slant, we can't count the spaces, we have to use the distance formula. So now if I want to find the length of AE, we're going to take the square root of the difference of the x's, -2 minus a -4 quantity squared, plus the difference of the y's, -3 minus 3 quantity squared. We've got that minus minus is plus plus, and so -2 plus 4 is going to be a 2 squared is 4, plus -3 minus 3 is a -6 squared is 36, and that's going to give me the square root of 40. So if I plug that into my calculator, I get about 6.3. Well, now that I know all three sides, I can find the perimeter by adding the 6 plus the 2 plus the 6.3 to get a perimeter of 14.3. Let's look at our last two problems in Chapter 1, dealing with our angles. In our first problem, it says that BD bisects angle ABC. Bisect, remember, means to be cut into 2 equal parts. So now I can go ahead and set up my equation. 6x minus 9 is equal to 2x plus 19. To solve my equation, I'm going to subtract the 2x from both sides and at the same time add the 9 to the 19. That's going to give me 4x is equal to 28. And so we get that our x is equal to 7. If I want to find the whole angle, well, since my two angles are equal to each other, I'm going to plug the 7 in up here. So 6 times 7 minus 9. And that gives me an angle of 33 degrees. So that means that my other angle also has to be 33 degrees. And so my whole angle ABC is 33 plus 33, which is 66. Now in our next problem, we're not told that our angle is bisected. We're given the two parts inside. This is our angle addition postulate. And this says that the two parts inside have to add up to the whole angle. So since that whole angle is 145 degrees, I'm going to take the two parts inside, 2x plus 10 plus 4x minus 3, and that has to be equal to 145. Again, combining my like terms, I'm going to get 6x plus 7 is equal to 145. Subtract the 7 from both sides. And 6x is equal to 138. Divide by 6, and we get that our x is equal to 23. So then if I want to find my two angles inside, I'm going to replace that x with 23. So for my first angle, LKM, the top one, 2 times 23 plus 10 is 56 degrees. And then my bottom angle, MKN, 4 times 23 minus 3 is 89 degrees. And we can double check. If I add 56 plus 89, that adds up to the whole thing of 145. In chapter 2, we looked at our logic rules. If you remember your Give a Mouse a Cookie project, we took a look at our different inductive and deductive reasonings and our different ways of saying our different statements. The first thing we want to look at is an original conditional statement. It's converse, inverse, and contrapositive. Remember that both the converse and contrapositive are trying to con you, and so they switch the order. Inverse is in order, not. So again, both the converse and contrapositive are trying to con you. They switch the order. Inverse is in order, not. Contrapositive is switched order and not. So let's go ahead and practice with a conditional statement. If you are a guitar player, then you are a musician would be our original statement. So the converse is going to switch the order, and so we would say, if you are a musician, then you are a guitar player. The inverse is in order, not. So we keep the same order but stick not. If you are not a guitar player, then you are not a musician. The contrapositive is switching the order and not. So we start with the conclusion. If you are not a musician, then you are not a guitar player. So if you are not a musician, then you are not a guitar player. In 2.2, we looked at inductive reasoning and deductive reasoning. Inductive reasoning is the likelihood of something happening based on past events or patterns. Deductive reasoning uses facts, definitions, accepted properties, and the laws of logic to form a logical argument. So looking at which one would be inductive versus deductive, each time Monica kicks a ball up in the air, it returns to the ground. So the next time Monica kicks a ball up in the air, it'll return is inductive, following a pattern. B, all reptiles are cold-blooded. Parrots are not cold-blooded. Sue's parrot is not a reptile. These are all facts. Facts is deductive reasoning. And then our last one is, of course, your favorite, a practice improves. We are given that A, B, and C, D are equal to each other. We want to prove that AC and DB are equal to each other. So we want to prove that these two overlapping segments are equal to each other. Well, let's go ahead and make a statements and reasons table. And we know that step number 1 is always the given. AB is equal to CD. If we want to prove something about AC, then and DB, notice they both share this middle part BC. So let's go ahead and bring that guy in and say that BC is equal to BC, and that's reflexive. Now look at, I have the two parts over here of AC, and I have the two parts over here of DB. So now I can use the addition property and add straight down, and I've got that the parts are equal to each other. AB plus BC is equal to CD plus BC. And that's the addition property. Well, that's great that I'm saying things about the parts being equal to each other, but I haven't said anything yet about AC or DB. I've got to bring those into the problem. And that's our good old segment addition postulate. So in step number 4, I'm going to go ahead and say that AC is made up of his two parts, AB and BC. So AC is made up of his two parts, AB plus BC, which I see in step number 3. I'm going to do the same thing about DB here. It's made up of his two parts, CD and BC. And anytime I want to say the two parts of the segment add up to the whole thing, that's the segment addition postulate. And so now I just have to get AC and DB on the same line, and I can do that with substitution. I can put AC in to the beginning part of step number 3 here, and I can put DB in for his parts in the second half of step number 3. So I can replace the wholes with the parts, and by substitution, AC is equal to dB. You guys will now go ahead and complete chapters 1 and 2 in your review packet that you're going to get.